Alright, welcome back. We are reviewing atomic theory. Last time we ended on this slide with ions and isotopes. Once again, we're coming to you from room 405 in the Science Hall with Mrs. Walton. So let's do a little practice on ions and isotopes as a refresher. What is the way that we remember these? Remember, ions are electrons and isotopes are neutrons. So when we have an ion, our number of electrons changes. When we have an isotope, our number of neutrons changes. Now we have two types of ions, cations, which are positive. Cats have paws. They lost an electron. And anions, which are negative. They gained an electron. Seems kind of opposite that you'd be positive if you lost something. But we're positive because we lost a negative charge. We're negative because we gained a negative charge. So here's an example. Sodium 1+. He's got a plus here, so what is he? He's a cation, which means he lost an electron. How many electrons does sodium usually have? Well, look at your periodic table. He's number 11, so he normally has 11. So if he lost an electron, how many does he have now? 11, do the opposite, minus 1 is 10. Okay, so hopefully we can get in that mindset. Now, flip gears here and look at isotopes. We have our number of neutrons here that are changing for isotopes. This means they don't have a charge, and you can see it multiple ways. You can either see your symbol with your mass on top and your atomic number on the bottom, which is opposite of the periodic table, or you can see the symbol dash the mass. Now this might look very similar to our plus over here, or our minus that could be up here. That's not the case. This is like hyphenating a name, okay? You don't consider this to be an exponent like you consider this. So we have hydrogen 1, hydrogen 2, and hydrogen 3. Compare these to your periodic table and see which one is the most common isotope. So if you look at number 1 on your periodic table, hydrogen normally has a mass of 1. So hydrogen 1, another name for its protium, is our most common form of hydrogen. Hydrogen 2 and hydrogen 3 here are our isotopes that deviate from that. Let's do a little bit of practice. Okay, so if we look at these guys, we should be able to state the number of protons, neutrons, and electrons. Find K on your periodic table. If you have trouble finding him, you have a little hint here. On the bottom is our atomic number. So find number 19 on your periodic table, and it's really easy to fill in protons because that tells me how many. So we can fill in our protons over here and say, okay, we have 19 protons. Now how many neutrons do we have? We have to take our atomic mass minus our atomic number, and we'll get out 20. How many electrons do we have? Well, we normally have the same number as our atomic number, so 19. And what do we have to do because of our plus sign that's up here? Do the opposite. Subtract 1. Because if it's positive, we lost an electron. We're going to have 18 electrons. Now tell me, what type of ion is this? It's positively charged, so it's a cation. And is it an isotope? Check your periodic table. What is the mass of potassium normally? It normally has a mass of 39.1. We can round that down to 39 and check it out. It is not an isotope, or it is the most common isotope, if you want to think of it that way. Okay, pause it and try this next one, and then come back and see what we get. For this guy, we're going to find oxygen on our periodic table. He's number 8, and that means we have 8 protons. To find my neutrons, I'm going to do 16 minus 8, which gives me 8. And for my electrons, I'm going to do 16, and since I have a minus sign here, I'm going to add 2. So I'm going to have 18 electrons this time. And that means that he's negatively charged, which makes him an anion. Is he an isotope? Look at the mass of oxygen. It's normally 16, so this is the most common isotope. So by North Carolina standards, we say that that's not an isotope. Okay, last but not least over here is calcium. Find number 20 on your periodic table, pause it, come back, see if you got him right. He has 20 protons. His neutrons are going to be 41 minus 20, which gives me 21. And my electrons are going to be 41. Do I add or subtract 2 here? I do the opposite, I subtract 2. So he has 39 electrons. And since he's positively charged, he's a cation. And check your periodic table. Calcium's normally 40.08. That would round down to 40, not up to 41, so this is an uncommon isotope. Okay, nice job. Alright, a little more practice. What if we see it this way? Let's figure out what we've got. If it has 8 protons, look at your periodic table, find something with the atomic number 8, you're going to have oxygen. And then if I want to write this like a proper isotope, what I'm going to do is put my mass up top. So I get that by adding my protons and my neutrons to get 16. So my 16 is going to go up top. And then on the bottom, I need to put my atomic number. What's my atomic number for oxygen? It's 8. That never changes for oxygen. And last but not least, I need to find out if I have a charge. So are my protons and electrons equal? They are, so I don't have to put any charge over here. Is this a cation or anion? No. Is it an isotope? Check your periodic table. No, it normally weighs 16. Okay, how about this next one? Number 17 on the periodic table is chlorine. Make sure it's big C, little l. What number do I put on top here? I'm going to take my protons plus my neutrons. So 20 plus 17 is 37. That number will go on top. And on the bottom, I'll put my number of protons, my atomic number, which is 17. And now I need to figure out my charge. Are my protons and my electrons equal? They are, so there's no charge. Is this an isotope? Check your periodic table. Normally, chlorine is 35.45, which would round down to 35. This is 37, so it is an isotope. Pause it and try this last one and come right back. 47 protons, silver. What number do I put up top here? I need to put my protons plus my neutrons, so 107, which is 47 plus 60. And on the bottom, I need to put my atomic number, which is 47. And then I need to figure out my charge. How do I do that again? I figure out if my protons and my electrons are equal. Well, right now I have 47 protons and 46 electrons. So I have more positives than negatives. One more to be exact. I can either write just a plus sign or +1. Both are correct. And put it to the top right corner. That makes this guy an what? Cation, anion. He's positive. He has more protons than electrons. Cats have paws. Cation. And let's check if he's an isotope. Normally silver is 107.87, so it would round up to 108. So this is an isotope. Good. All right. So hopefully you feel good about ions and isotopes. Let's talk a little bit about the octet rule. The octet rule says that every element should have a full outer shell. For most elements, this means they would have 8 electrons, unless it's hydrogen, helium, lithium or beryllium or boron, who want to get down to 2 in their inner shell, because remember the first shell only holds 2. The goal of every element is to be stable. Well, who's the most stable? Those guys in the noble gas column, so that's who they want to be like. Okay, and what would they act like if this happens? They would act like the noble gas that they're turning into. So, how about if we needed to count some atoms? Let's answer some of these questions here. What is this 3 out in front called? That big number. That's what we call our coefficient. he gets distributed to everything. So if you want to think about it as having big brackets around all that, you can. You want to use him last when you're distributing. If I want to know how many CAs there are, I need to consider how this is going to distribute in. So who will this 2 belong to? He's only going to belong to those guys who are inside the parentheses. So he distributes to these 2. He doesn't distribute to calcium. After you do that, okay, consider there to be brackets around everything. And the 3 goes to absolutely everybody that's part of this equation. Okay, so what we're going to do first is look at calcium. Okay, calcium originally had 6. This 2 doesn't go to him, so the 3 does, and we multiply. 6 times 3 gives us 18. Okay, so there are 18 calciums. How about phosphorus? Well, this 2 went to phosphorus, and remember when there's nothing there, it's a 1. So we did 2 times 1 is 2, and then we had to take our 3 and say 3 times 2 is 6. Okay, so there are 6 phosphorus. Now what if I consider the PO4 as a whole? Okay, this entire PO4, there were 2 of them, and they got multiplied by 3. So that actually means there were 6 PO4s as a whole. Let me get my text box here. Okay. But let's think about oxygen separately for a minute. Oxygen had this 2 that distributed in and did 2 times 4, which is 8, but I'm not done yet. This 3 also distributed in. 8 times 3, 24 oxygens. Let's make a list over here of how many of each thing there are. Calcium, we decided that there were 18. Phosphorus, we decided that there were 2 times 3, which is 6. And oxygen, we decided that there was 2 times 4, which is 8, and 3 times 8, which is 24. If I want to know the total atoms, okay, the total of all my atoms, I'm just going to add those up and do 18 plus 6, 24 plus 24 is 48. I'm doing all this in my head, so I hope we're right. So there are 48 total atoms in this equation. Okay, if we want to think about the total elements, how many different elements do I have here? I have calcium, phosphorus, and oxygen, so there are a total of 3 elements and 48 atoms. Okay, and the last question here says, what's this little 6 called? This 6 is what we call a subscript. I'm just going to return down here. Subscript is what we call that little 6. Hopefully that's a good little refresher for you. If you're not sure how that went, have your teacher write it out for you because it'll look a lot better on paper. Okay. Alright, so next time we're going to talk a lot about bonding, but I just want to give you a quick little preview of it in the last about minute and a half of this video. Remember that a compound is 2 or more elements chemically bonded together. They're not just hanging out in a mixture, they're actually bonded. And they form because there's attraction between those elements. They want to fulfill the octet rule and become stable. Now there are different types of bonds. We have ionic, metallic, and covalent. Ionic bonds form between metals and nonmetals. Okay, and recall to your periodic table that they have to be on opposite sides, or it can be a metal plus a polyatomic ion. Those are on the back of your periodic table. Metallic, okay, forms, between 2 metals. Get over here. 2 or more metals. And covalent forms between 2 or more nonmetals. So those are the important ways to distinguish between these 3 types of compounds. Next time we'll talk about how they actually make a bond. Alright, keep working hard guys, finals are almost here.